This episode brought to you by Danfoss, engineering solutions that increase productivity, reduce emissions, lower energy consumption, and enable electrification. Learn more at danfoss.com. Well, hello everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC Podcast. So today we're spending some time with Dean Groff, Sales and Service Manager, Danfoss. How are you, sir?
Doing fantastic, Clifton. How are you?
I'm doing great. I'm very excited about our industry. I know it's a transitional time and a lot of people are struggling with changes and transitions and regulations, but I actually find it fascinating. You know, as a refrigeration technician, I really spent most of my time in that CFC to HCFC transition into HFCs and spent a little bit of time with A3s, primarily like R290.
Yep.
So I came out of the field about 7 years ago as a commercial refrigeration technician. And things like CO2 were just starting to hit the market in new construction. And many of our educators, like myself, have came out of the field, probably been out for a few years, and may not be comfortable with CO2. But it really is like the emerging refrigerant in our industry, wouldn't you say?
Yeah, I would think. I mean, at this point, from what I'm seeing, especially in the food retail side of the world,
Mhm.
yeah, overwhelmingly, all of your big players, for at least new stores, are going CO2. On retrofits, there are some fluctuations out there on what direction it's heading, but predominantly, you're seeing CO2 more and more.
Okay. And now, are we seeing many challenges, especially in that food retail industry, as we're moving into these, ultra low GWP refrigerants like CO2?
Yeah, if you look at CO2, I think there were some challenges here, especially in North America, where there just wasn't a strong knowledge base on the technician side of it
Yep.
on how CO2 operates, especially when it goes transcritical and all the things that you have to think through on that. And also at the same time, you're introducing a lot more controls into the system. They're controls that they never dealt with before. I like to think about it as going from a carbureted engine to a fuel injected engine, right?
Exactly.
I tell technicians when I'm talking to them, if you're not bringing a computer to the job site, you're not going to be able to work on this stuff.
Yeah. Yeah.
It's just the reality of where we're at.
Yeah, and it's important for us to understand that and help prepare our students for these
Hmm.
technologies. You know, many of our educators, especially ones that, may have been out of the field for a while,
Hmm.
might not have been at that place in the industry where they were using, digital tools as part of their daily work. But even 7 years ago, I had an iPad in my tool bag, right?
Yep.
I had my hand tools in the back pouch was the padded zippered spot for my iPad, and
Hmm.
everything that I worked on I pulled up, right? And I was using things like Site Manager and Ultrasite, and where I could be off site and look at my own pieces of equipment. And
Yeah.
so it really is a very important part of today's HVACR technician. And incorporating that into the classroom could be a difficult thing if you're not comfortable with it. But we're here to let you know that you have resources, you have
Oh,
Danfoss, you have
absolutely.
manufacturers.
There are a ton of resources out there. I mean, if you look at the agencies, you look at NSARC and what they're doing with their training summits and getting out there. I mean, they're focused on not only the theory of CO2,
Yeah.
but also how do you launch it, how do you implement it, how do you get it to work, and it's important that all the players from the commissioning engineering and techs out there to the sustaining engineers that they understand what they're doing and what each one of these components do in the system, because it doesn't take much in a CO2 world to blow a charge, right? I mean, the tolerances are just so small there.
Exactly. I'm glad you brought up, NASRC. We're actually
Mhm.
doing a co-release of a, introduction to CO2 training for the classroom, particularly for educators to get comfortable with this curriculum. Really an
Yep.
introduction into it, because there are some things that are different, but there's a lot of benefits. Like,
Mhm.
can you like talk us through like some of the benefits of going to CO2 over some of our traditional refrigerants, say like 404s and.
Well, I mean, first of all, you got the GWP, right? So
Mm,
you're doing good things for the environment there, and quite frankly, at this point, you're going to have to change to something anyway, right?
something, yeah.
At some point, you're going to have to do something with your refrigeration, whether you go to CO2 or you go to an HFO or whatever. I think
Hmm.
that's a decision that each independent end user needs to make, right, on what's best for them.
Right.
But if you look at CO2, it pretty much future proofs you, right? I mean, the GWP is non-existent, and if you once you learn it and you get it to work and you're already changed over there, you're done. You don't have to do any
Exactly.
more for the life of that equipment. I think if you look at some of the other refrigerants out there, there is some risk, right? And not that there's not
Mhm.
risk with CO2. You've got the implementation risk, right? What do you do with transcritical and the pressures and things like that? You've got to think through. But then with some of the other solutions, you've got risk on what's going to happen with the PFAS, right?
Boy,
That's a
yeah,
little bit unknown right now. But
it really is.
I think if you talk to all of the end users and educate them, and it's up to them. What's the best solution for them? I don't think it's a one size fits all solution. So.
No, you're right. And I think that's important for us to discuss. If I'm a business owner or if I'm a
Hmm.
property manager and I'm looking at what those solutions are, a lot of times it comes down to initial cost and investment. But
Yep.
like you said, there are a lot of factors we have to look at. Most of our existing stores, if they're going to be looking at that potential retrofit, they're probably
Hmm.
working with an HFC refrigerant now,
Right.
high volumes of HFC refrigerants. Most of my stores would have around 2,000 pounds to 2,500 pounds of refrigerant.
Hmm.
Once in all the combinations of the different medium temp and low temp racks and air conditioning. So as we start looking at those large quantities of refrigerant, those HFCs are getting very expensive and are going to go through a short supply as
Yeah,
we
I mean
continue to phase
that's the
down.
intention of the AIM Act, right?
That's right.
Part of that is reducing the supply,
Hmm.
and if you take what we learned in Europe, you reduce the supply, and you can get some very large impacts on the price of refrigerant, doubling within a matter of weeks. And it will get to some point where you just can't afford to refill your system.
Yeah, absolutely. One of the topics that you brought up is one that it's I wouldn't say it's a controversial topic. It's one that we need good education on, quality education on what PFAS is
Hmm.
and what some of our alternative refrigerant solutions are. Because when we look at refrigerants, there is no perfect solution, right? Our
That is
perfect
correct.
solution
Yep.
is H2O. We're just probably not going to get there anytime in the near
Yep.
future. So when we look at refrigerants, whether you go with a natural like a CO2 that may have
Hmm.
higher operating pressures, well, if you look at some of the others like our HFOs, some are newer refrigerants, some are actually older refrigerants that we haven't used. You'll take
Yep.
things like R1234YF. When you
Hmm.
look at things like that's tetrafluoropropene, it was
Hmm.
actually patented in 1960, right? It's a chemical that's been around for a long time. It just didn't really find its right fit until
Hmm.
recently when we started re-looking at some of these lower GWP refrigerants that are mildly flammable. And so many times we have to weigh what those options are as a business owner
Yep.
versus just a single refrigerant solution. Because some of these HFOs are mildly flammable, which could throw in a
Hmm.
whole different perspective when we're looking at refrigerant management.
Yeah, I mean, you just look at the at 2-89, right? That you've got to
Mhm.
comply to with any A2L.
Yep.
The three pillars of that. You've got to find a leak, detect it in a certain amount of time. You've got to react to that and isolate it. Then you've
Mhm.
got to mitigate it with something. How you implement that is, I mean, there's different strategies out there, but it's a risk, and it's more controls, right? And you're back to the control aspect of it. Even when you look at the air conditioning systems that are going to be on the roof, more
Yep.
controls in those. Same issue. They're A2Ls.
Yeah. When we think
Hmm.
about these things that we need to know, we talk about like mitigation.
Hmm.
Some business owners may be familiar with systems like this that we've used in the past. If you take an earlier generation grocery store that
Hmm.
had a compressor rack room where all of the compressors were in one room, it had louvers on the exterior wall and exhaust fans on the ceiling,
Yep.
and we had refrigerant leak detection in that room. The
Hmm.
whole principle was if we had a large refrigerant leak, we could actually open up fresh air from the outside and vent that refrigerant outdoors.
Yep.
That works well in that installation, but when we start looking at the rest of the components within the rest of the structure, that was never accounted for in our earlier generations. So if we look at things like mildly flammable, are you seeing a significant investment in these mitigation systems that would be used for, say, an A2L complete system?
Yeah, I've seen a lot of discussions around it. I have not physically seen one implemented in a store yet, but yeah, there's
Mhm.
investments being made on the control logic and also the line components, right, that go into all of that, right? The isolation and the mitigation portion of it.
Yeah, and there's a lot to understanding that. That's the reason we try to have our manufacturers come on the show and discuss
Hmm.
things so that we're not getting secondhand, third hand, fourth hand information.
Yep.
And as an audience, you can tell that a lot of these are new strategies that we are facing, and so we're really just now starting to implement a lot of these A2L mitigation strategies, which is why CO2, I believe, is such a good solution because it reduces a lot of that. And when we start looking at the replacements of refrigerants, the regulations behind CO2 are very different than other refrigerants. Is that anything that you can speak to?
You, as far as the
Like
leak detection and
reclamation and
mitigation and
venting and
reclamation,
Mhm,
yeah, I mean, for one thing, you could vent it.
exactly.
Um, so I don't know
That's a
whether
big
that's
difference.
necessarily an advantage. Yeah, there's a lot of discussions right now on what sort of bar do you actually design a system for,
Sure.
because even though CO2 is you can vent it legally, right? Is that
Right.
something you want to do? Because you do have
True.
a limited supply of stuff and it costs money.
Right.
So do you design the system to go up to 100 bar, or do you design it something lower and mitigate your risk as far as a blow off of refrigerant, right? How
Sure.
long can I go without electricity if that should happen before I lose a charge, right? And all those things are under discussion on where ultimately we'll end in designs here in the U.S. So
Yeah, which gives us a lot of options, and it depends on the region that the structure is in as well.
absolutely, yep.
There are situations where you may end up having a cascaded style system where you're using
Hmm.
CO2 within the store, but they're using a different refrigeration system with an HFO or potentially an HFC to move that heat from the CO2 to outdoors. Are you seeing very many of those systems being designed?
Some, yeah, some of them. I've seen more of that probably in the retrofit than the new store. New
Right.
store predominantly you're seeing either straight CO2, or if they're a smaller footprint store, you've also seen the micro distributed systems that use either like propane or an HFC, which
Uh,
is
tell,
another option that's out there.
tell me about that system.
It's just smaller, self-contained, either air-cooled condensers or water-cooled condensers.
So when we talk about CO2, we're primarily talking about the entire store. What applications are we using CO2 for? Is it a medium temp only application? Is it a low temp application? Can those systems be combination?
Yeah, so they can be combination. They're both medium and low temperature. The other thing that you can do with CO2 is you can recover the heat, right? So you can do things with that heat recovery because you've got a higher temperature there on the discharge. There's a lot of energy that you can make use of that we typically just blow off in the air, right?
Yeah, it's kind of crazy to think about the amount of heat that we actually just release back into the atmosphere instead of utilizing. I remember as a young technician, I worked in an older IGA. Here in the Midwest, we have a lot of IGAs that were built in the 1970s, 80s, and in the 90s.
Hmm.
And in this particular one, it was my first introduction into a heat recovery off from the refrigeration system, and it was a direct heat recovery off from the discharge of the compressors in the rack room that came back for domestic hot water heating
Hmm.
as well as heating within the building. And I thought, well, that's a brilliant idea. Why doesn't every building start utilizing technology like that? And so
Yep.
with CO2, I think we have that ability to start focusing on that more and using that energy instead of just releasing it into the atmosphere.
Absolutely. We've got Danfoss has a store that we have operating on our campus in Denmark that is a carbon neutral store, and it's all about managing your energy, right?
Mhm.
It's taking that energy, using it where you need it, and not just throwing it away.
Yeah, exactly. Because it's a significant amount of heat and the
Hmm.
energy that's used to just move that heat. And then in
Yep.
many times firing up gas fired appliances to be able to put the heat back into the structure. So
Yep.
it seems to be a waste of energy if we're not utilizing it properly.
Yep. And you're seeing more of that here in North America. So taking advantage of that extra heat recovery,
Yeah.
where you can, right?
Yeah, I've talked to many of our chiller manufacturers
Hmm.
that just came back from the Johnson Controls Advanced Development Engineering Center, where we're looking at heat pump chillers that are focusing on this because we're finally, as an industry, starting to look at, well, where do we need to put the heat? Because the beauty of using a refrigeration circuit is that we can move it. We're not creating, we're moving
Yep.
heat.
Hmm.
And so the applications become endless because what if I had a grocery store that is next to an apartment building and I'm in
Hmm.
the northern states? Well, I can pull all of the heat off from my products and I could even put it into a system where I'm actually using it as a utility that I can get back to other buildings, other facilities, and repurpose that heat instead of constantly generating and releasing and generating and releasing. We can now actually think about moving heat in a broader perspective.
Yeah, and then it goes back to using the energy that you have wisely, right? And not just
Exactly.
throwing it away.
Yeah. Yeah, for
So
sure. So, as we start looking at grocery stores going forward, there's a lot that's going to be required for training, not just of the building owners, but as the engineers, the designers, and technicians. What are you starting to see at Danfoss in training for CO2?
we started out early on, and I think the industry is doing a big lift here, right? And all of your component manufacturers and the OEMs are all supporting this, and it's trying to train just the basics of CO2, right? What happens subcritical, what happens transcritical, and I think we're well down the road on that. And you've got, like I said, NSARC that are supporting this, and other agencies, right, to
Right.
try to get that basic training out there. And I think we're at a point now where there's a pretty good solid understanding. There's still the rural areas, right, that don't have this training we need to get out there, but you've got a good understanding right now of the theory of CO2, right? So now you're looking at the control logic and what happens and how do you actually run the system. I was on a phone call the other day and there was a fire marshal and they wanted to do a test for the fire alarms. Well, we'll just shut it down and then fire it back up here in a little bit. I thought,
No,
need
you
to
don't want to do
rethink.
that.
We need to rethink this. Not that simple. But getting that fundamental understanding of what you don't do and what you do and how that logic happens on when a system shuts down and how you start it back up and those methodologies. So
And where could people learn more about like training that Danfoss offers, especially when it comes related to CO2 products?
we've got a training page just dedicated for CO2 on its own. I'd have to look up the address. I'll email that to you. But
Sure.
if you just Google Danfoss CO2 training, there
Mhm.
are probably 4,000 plus hours of training out there on
Wow.
different concepts, different controls, different systems, everything from basic operation to advanced controls. And then we also have our own training where we'll train you on controls. And we also have a mobile training unit that we're getting ready to launch and take around the US.
Yay.
It's designed to be representative of an actual rack.
Mhm.
So when the technicians get there, they're going to be looking at it. The controls will be there. It's got the compressor sets there. It's got the gas cooler there, and you're able to open and shut louvers to adjust the load, where you're seeing the compressors ramp up from variable speed. You're seeing the ejectors, as this has got an ejector system on it, kick
Mhm.
in, and that's where you're starting to see the technicians, or at least where I've used it. It starts to click from theory to application, right? And then you see the light bulb go off, like, now I understand what's happening.
Exactly.
And there are a lot of companies out there that have these type of systems that are training, not just Danfoss.
Well, we sure appreciate the commitment that Danfoss has to education in the industry. I encourage everyone to go to danfoss.com, learn a little bit more about what's happening with Danfoss, and do some searching for the CO2 training. We'll put links to that into the description of the video. And Dean, I sure appreciate you joining us, and I hope to dive a little bit deeper into these conversations in the future.
I hope so too. And I think if there's one thing that I could leave with the technicians out there is learn CO2. It's coming. It's not going to go away. Learn it, and you're going to be set for a long time.
I completely agree. Well, thank you very much for joining us.
Thank you, sir. Have a good day.